Lewis structures are a simple way of describing the bonding between atoms in a molecule. It's a pretty simple system, but it has it's pretty accurate, so we use it a lot. And once we draw these, then we can use them to predict how a molecule will act. Drawing a Lewis structure is pretty simple, and the first step is to find out how many valence electrons the molecule shares. In general, and specifically for this class, it's only the valence electrons that bond, and so we are only interested in those, not how many electrons it has total, but how many valence electrons it has. We do that by cataloging what's there. So in this molecule, in silicon tetrachloride, we have one silicon atom, and we have 4 chlorine atoms. Now if we look at the periodic table, we see that silicon is in row 14, which means it has 4 valence electrons, and chlorine is in row 17, so it has 7 valence electrons. So silicon contributes 4, and each chlorine contributes 7, so multiply that by the number of chlorines that there are. So silicon contributes just 4, and the chlorines contribute 28. So we have a total of 32 valence electrons here. Now, generally, whatever element is single, meaning there's just one of them in a compound, will be your central atom. If that's not the case, or if there's more than one that are single, I'll always let you know which one is the central atom. Since there are 4 chlorines, these are going to be what we call terminal atoms, and we'll write them around the outside of the molecule. So now we have our basic structure of what it's going to look like, and we need to start distributing these 32 electrons. The first place to distribute them is the bonding electrons between the different atoms. So we're going to put 2 here, 2 here, 2 here, and 2 here. We always distribute them in pairs because they act as pairs. When they're bonding, it takes 2 to bond, and then we consider the rest lone pairs. So we always do them in pairs. So 2, 4, 6, 8. Now we'll distribute more on what we call the terminal atoms. This is 8, 10, 12, 14, 16, 18, 20, 22, 24, let's see, 26, 28, 30, 32. Okay, so that's exactly what we need. Now, we need to just go back and make sure that all of the atoms have 8 electrons around them. Since they share them, that means this chlorine has 8 right here, and this chlorine has 8 right here, and this one has 8, and this one has 8, and silicon in the middle also has 8. So this is a good Lewis structure of silicon tetrachloride. Now the number of electrons you're distributing is not always going to be exact. For example, if we do the Lewis structure of silicon dioxide, again we have 1 silicon atom, and this time we have 2 oxygen atoms. So silicon, when we look at the periodic table, again, is in the 14th column, which means it contributes, or it has 4 valence electrons, and oxygen is in the 16th column, which means it contributes 6 electrons. So silicon, there's just 1, and it has 4 valence electrons, and oxygen has 6 valence electrons, and there's 2 of them, which means that there are a total of 16 electrons in this Lewis structure, valence electrons. Now silicon, there's only 1, and there's 2 oxygens, so silicon will be in the middle, oxygen will be our and oxygen will be our terminal atoms, and the first electrons that we distribute are the bonding electrons. So we put 2 there and 2 there. So now we're at 4. Then we add them to the terminal atoms, 4, 6, 8, 10, 12, 14, 16. Okay, so we ran out of electrons. But when we go to check and see if everybody has 8 in their valence shell, we see that silicon is not happy. It only has 4. And it's most stable with 8. So So what we do in that case is we take some of these electrons from the ones that are full and we add them to the center. And that allows the sharing of more than one pair of electrons, and it allows everybody to get the 8 that they need. So now oxygen has just 4 lone pairs, and there's 2 bonding pairs between silicon and oxygen, and this one has 2 bonding pairs between them, as well as 2 lone pairs over here. Now let's check and see how many electrons are in each valence shell. This oxygen has 8 still, this oxygen has 8 still, and silicon also has 8. So the Lewis structure of silicon dioxide has 2 double bonds in it. You can also draw a Lewis structure of not just atoms, but polyatomic ions. In this case, let's try cyanide. So carbon contributes some, nitrogen contributes some, and remember that these charges, whether it's positive or negative, are talking about the number of electrons, so we need to add that into our consideration of how many valence electrons there are. So let's look at our periodic table. Carbon is in row 14, so it has 4 electrons, and nitrogen is in row 15, so it has 5 valence electrons. Carbon has 4, nitrogen has 5. An electron, it has a negative charge, which means it has an extra electron, so we'll add that electron in here as well. And that gives us a total of 10 electrons to distribute. In this case, there's no central atom since there's only 2 atoms, so we'll just write them next to each other. And then we'll be sure to put brackets with the charge on the outside, because it's a polyatomic ion, so we need to remember to include its charge. To make sure that charge doesn't get confused with all the dots of the electrons, we put the brackets around it. Okay, so we have 10 electrons to distribute, and we'll add the first ones as bonding pairs. And then we'll add around the outside, so 2, 4, 6, 8, 10. And that's all the electrons that this system has, and so we can't keep adding electrons. The only thing we can do is rearrange these electrons so that everybody gets 8. Right now, carbon has 6 and nitrogen has 6, so neither one of them has enough electrons in their outer shell. But we can move these electrons here and these ones right here to give us a triple bond, and that will give us 8 in each outer shell. So then now carbon has all 8 here, and nitrogen has these 8 here, and everybody has a stable valence shell.